s is equal to initial velocity plus half at squared. For 10 seconds, the distance s is equal to 0 plus half times 10 raised to power 2, which will give us 200 meters. Also, for 9 seconds, s is equal to initial velocity 0 plus half times acceleration due to gravity, which is 10 times 9 squared, which will give us 405 meters. Therefore, the distance covered for the last 1 second of its motion is 500 minus 405, which will give us 95 meters. Question 5. A block of mass 2 kg resting on a smooth horizontal plane is acted upon simultaneously by two forces, 10 Newton due north and 10 Newton due east. Calculate the magnitude of acceleration produced by the forces on the block. Solution. Since the force is magnitude is 10 Newton due north and 10 Newton due east, the resultant of the force will now make the force to have a resultant in a right angle triangle. Using the Pythagoras rule, we say that the square root of the hypotenuse is equal to the square root of the other sum of the other two sides. We have that r squared, which is the hypotenuse and the resultant, equal to the 10 newtons due east squared plus 10 newton due north squared, which will give us 200. Making r the subject of the formula, we cross the square to the other side to become the square root of 200, which is the same thing to be square root of 2 times square root of 100, which will also equal to 10 times square root of 2 Newton. Using the force formula, which is force F equals to ma, we have already gotten the resultant force, which is 10 square root of 2 is equals to 2, that is the mass of the body times acceleration. Since we are looking for the magnitude of the acceleration, we now make the acceleration the subject of the formula, which is a. We now have 10 square root of 2 divided by 2, which will give us 5 square root of 2, which is also the same thing as 7.07 meters per second. That means that the magnitude of the acceleration is now equal to 7.07 meters per second squared. Question 19. The resultant of two mutually perpendicular forces F1 and F2 is 13 Newton. If the magnitude of F1 is 5 Newton, what is the magnitude of F2? Solution. From the law of Pythagoras, square root of hypotenuse equals to the sum of the square root of the other two sides. We have that r squared equals to f1 squared plus f2 squared. Given that the resultant is 13 squared, we now have 13 squared equals to f1 squared, which is the unknown, plus 5 squared. Making f1 the subject of the formula, we now have 13 squared minus 5 squared, which we now have f1 to be in square root of, in brackets, is 169 minus 25. F1 will now be square root of 144, which will give us 12 Newton. Question 20. Find the resultant of the system of forces shown in figure 1.57 below. Solution. Resolving horizontally, we have 6 plus 4 sine 30 degree is now equal to 8 Newton. Resolving vertically, we have 8 plus 4 cos 30 degree, which will give us 11.46 Newton. The resultant will now be, since it is now in a right angle triangle, we now have resultant using the Pythagoras theorem, which states that the square root of the hypotenuse is equal to the square sum of the squares of the other two sides. R squared is now equal to 8 squared plus 11.46 squared. R squared is equal to 64 plus 131.33. R squared is now equal to square root of 195.3. Then the R is now equal to 13.98 Newton. Chapter 2. Conservation Principle. Work, Energy and Power. Contents. Conservation Principle. Chapter 2.1. Work, Energy and Power. Chapter 2.2. We have application of mechanical energy. 2.3. Linear momentum. 2.4. Temperature measurements. 2.5. Expansivity. 2.6. Gas laws. 2.7. Measurement of heat. Work. Work W is defined as the product of force F and the perpendicular distance displacement x in the direction of force. Work W is equal to force times distance moved in the direction of force. W is equal to Fx in joules. The SI unit of work is joules. Example 1. If an engine force of 1000 Newton pulls a boat 50 meters, calculate the work done. Solution. Work equals to force times distance moved in the direction of force. Work equal to 1000 times 50, which is equal to 50,000 joules. Energy. Energy is ability or capacity to perform work. Kinetic energy. This is the energy possessed by a body in motion. Kinetic energy equals to Ke is equal to half mv squared, where m is the mass of the object moving with a velocity v. The SI unit of kinetic energy is joule, J. Proof. Consider the work done to set a stone of mass m kg in motion using catapult. Kinetic energy equal to work done is equal to Fx, taken to be equation 1, where F is force and x the distance before the stone is projected, but F is equal to ma, where a is the acceleration of the stone. Fs is equal to mas. This will now take to be our equation 2. And since initial velocity u of the stone starts from rest, u is equal to 0, and so we have that v squared is equal to 0 plus 2as. That is, as is equal to v squared over 2. Substituting as equals to v squared over 2 in equation 2, we have that F times S equals to m times v squared over 2. Therefore, kinetic energy is equal to half mv squared.